I had to take Wonder class, so I missed it.
Okay, did you watch the recording?
No, I didn't get a chance to yet.
Okay. Make sure to watch the recording after class. So what we did was we went over exponents and we went over radicals. So if you need a review of any of that, or if you do need to learn them, you have to watch the recording. So we will be covering the homework. So we will be covering the most missed, top 5 missed questions, the top 3 missed questions, sorry. Okay, so in the chat, please answer. And also we will be keeping track of points today. So everybody who did the homework in the chat, what is 5 to the power of 2, all of that to the power of 3?
Excuse me?
Yeah.
I didn't know there was homework to do, so I didn't even know where it was.
It's on the Google Classroom. You should be able to see it here.
Yeah. Yeah, I see it.
Yeah, it should have been right here.
Yeah.
So yeah, you should have just clicked on this and then done it.
Okay, I'll do it probably after class.
Okay. So problem, the most missed question was 5 to the power of 2 to the power of 3. So I think people are answering in the chat. Yeah. Okay, so it's 5 to the power of 6. The answer in the quizzes was wrong. So if you remember the rules from last class, you'll remember that when something is raised to the power of something else, and then that is raised to the power of something else, you multiply these exponents together. So you would get 5 to the power of 2 times 3, which is 5 to the power of 6. And that would mean your answer would be B. So if anybody has any questions about that in the chat, just put them or unmute.
I have a different question.
Okay.
My mom got some email or text, so like the top 5 from both classes.
Yeah.
She was confused on what that's about.
So basically, what it is the standings. So in the standings, we take the homework score and we add the participation points. So participation points are like when in class you ask a question, you answer a question, you answer a problem, you get it right, or you explain a problem and you get it right. So we add those up, and basically it's just like your score. And based off of that score, we have the ranking, which is the top 5 kids who were, which was what was in the Google Classroom.
All right, everyone, make sure your name is set to your actual first and last name. That'll help a lot when keeping track of your points.
And also someone else in the chat said homework quizzes link is not working. So the quizzes link for the first homework should not, you will not have access to it because it closed at yesterday at 3 o'clock. So because we needed to put it in the standings. So make sure you do the homework on time or early because we are unable to like reopen it. So yeah, sorry.
Okay, moving on to the next problem. Like before, go ahead and put your answer in the chat if you did this problem. Okay, so let's work through it together. So first, we have 2x, the quantity of 2x squared, y to the 4th, everything cubed. So what we have to do here is go and cube every single term in this. So we do 2 cubed, which is 2 times 2 times 2, or 8. Then we do x squared cubed, which, like we did in the previous problem, you have to multiply the exponents. So that gets you x to the 6, x to the 2 times 3, which is 6. And then same thing for y. So y to the 4 times 3, which is 12. So if you said C, you got that correct. Good job.
Okay. If anybody has any questions, feel free to unmute or type them in the chat at any time. And then the third most missed question was simplify the following expression, 16 to the power of 1/4. So in the chat, put your answer. Okay, so I'm seeing a lot of answers of A, and that is correct. So what we would do is, so what 16 to the power of 1/4 is you're trying to find the fourth root. So basically the fourth root is using our exponent rules. We know that this is also 16 to the power of 1/2, all of that to the power of 1/2, right? And we know that 16 to the power of 1/2 is the square root of 16. So what you would do is you'd get 4, right? And then we would find the square root of that, because that's what to the power of 1/2 means, right? And the square root of 4 is 2. So you would get 2 as your answer, which is A. Okay. So if anybody has any problems or questions about the problems, please ask them right now, so we can go over them. And if not, also put that in the chat. Okay.
All right, great. So we're going to move on. The big topic for today is logarithms. Now, for a logarithm, it's written out in this form. So first you write the words log, and then below it is like a subscript, and that number is the base of the logarithm. Then you have parentheses, and inside the parentheses is called the argument. And finally, that equals an exponent. So this might seem similar to what you learned about exponents, like the terminology base exponent. You can see down there a picture of a logarithm. So log base 3 of 81. 81 is the argument, and that equals 4. All right, so we're going to explain a little more about how this works, in case you're a little bit confused right now. A logarithm is just another way you can write an exponent. So you see there, 3 raised to the power of 4 equals 81. And that would be an exponential form, which is probably something you're very familiar with. But now we're going to ask the question, 3 raised to what power equals 81? And that answer would be 4. So if you're asking questions like these, you would write this in the form of a logarithm. So like before, log base 3 of 81 equals 4. And you can see, hopefully no one here is colorblind. You can see that the colors correspond to each other. So like 3 in both of them would be the base, and then 81, and then 4 is the exponent. So basically it's just a logarithm is just an exponent that's rearranged.
Okay. So logarithms and exponents. So exponential form just looks like a to the power of b equals c. And a logarithmic form is just a rearrangement of that. So log base a of c is equal to b. So why is this useful? So in the chat, why do you think logarithms are useful? Okay, so Okay, so some people are saying it makes exponents easier, and that is true. So if you need to solve for an exponent, you can easily plug in log of base whatever of a is equal to what and get your answer rather than having to do trial and error. And this is especially helpful if the exponent is irrational or if you don't have a lot of time. And problems concerning population or growth, which you will not get into much in this course. However, it is sometimes used in math counts. It's also used there. And when problems are given involving log, you'll know what you're doing. Sometimes they just give like, find the answer to this equation, and it includes log, and it would be useful to know log for those situations. Okay. So now we're going to do a few practice problems, and obviously we haven't really said much about it, since it's just exponents in a different format. So you might have questions, right? And if you have any questions, put them in the chat. And when you're doing each problem, put the number of the problem and then put your answer. And if you want to type like log base a of c is equal to b, then just type log and then put the number, and then in the parentheses put the c is equal to whatever. So like that. Okay. So you guys will have 6 minutes to solve these. So put your answers in the chat, and if you don't know how to do something, just private message either me or Yolanda.
Oh, and I would definitely suggest writing like that rule you see in the top right-hand corner down on a piece of paper. It'll just help if you forget.
Okay, 2 more minutes. But I'm seeing most people have gotten up to 4, so that's good. And if you're struggling, again, private message either me or Yolanda, so we can help answer any questions you have.
Excuse me?
Yeah.
So this one person keeps direct messaging me, and then so whenever I write a message in the chat, it keeps direct messaging him instead of you.
Okay. Okay. That's fine. So long as you are doing the problem. And just make sure to message them and tell them not to do that, because they might not be aware that they're doing that. Okay, so it's 3:17, so we will now go over the problems. So I will do the first one. So basically, we know that a to the power of b equals c. Okay, wait, sorry. Okay, so we know that a to the power of b equals c is also log base a of c equals b. So that means that we can take this a as 3, right? So we get log base 3. And then we have c, right, which is 9. So log base 3 of 9 is equal to, and then that's b. So b is the exponent, and that is 2. So that means that for our first problem, we get log base 3 of 9 is 2.
All right, so for number 2, that's basically just the same thing. So a, or the base, would be 2 right there if you look at the rule, and then 10 would correspond to b, and then 1024 corresponds to c. So you just write that in logarithm form as log base 2 of 1024 equals 10.
Okay, for the next problem, we have a fraction. However, it would still work the same way. So what we would get is a is equal to 8, right? So we get log base 8. And then we have c, which is 4. So log base 8 of 4 is equal to, and then we have our b as 2/3. So log base 8 of 4 is 2/3. So that is our answer.
All right, so now we're going to move to converting logs to exponents. And it's basically the same thing, just in reverse. So a is that small 4 right there. That's the base. So we'd write 4. And then b would be the 3. That's the exponent. So you raise 4 to the 3rd power. And then finally, c is 64. So 4 to the 3rd equals 64. And you can check yourself because obviously 4 times 4 times 4 equals 64. So your answer makes sense if you got that.
Okay, for the next problem, log base 5 of 3,125 is equal to 5. So we get 5 is equal to a. So we get 5 as the base. And then we get our c is 3125, right? Or this value. So 3125. And then, sorry. Okay, 3125. And then we get our value of 5 over here as the exponent, or b. So we get 5 to the power of 5 is 3,125.
Okay, and finally for 6, 2 is a, -1 would be b, and 1/2 would be c. So you get 2 to the -1, negative first power equals 1/2. And if you remember from the previous class, when you raise something to a negative power, that's just saying how many times you should divide 1 by the base. So here it's -1, so we divide 1 by the base to the first power.
Okay, so if anybody has any questions, feel free to unmute. And if not, we will move on. Okay, so we have 3 challenge questions. So write what the value of these each would be. So log base 8 of 1 would be equal to what? Log base b of b to the power of x would be what? And b to the power of log base b of x is equal to what? So in the chat, put your answers. And you have 3 minutes. Or sorry, 5 minutes.
And
And
it's okay.
remember, wait, sorry. Remember to write it in exponential form so you know what exactly, like if your answer makes sense and what exactly you are solving, because you can easily get the wrong answer and not be able to check it if you don't write it in exponential form. Okay, so we have many answers for one, so I'm just gonna go ahead and solve, right? So we can say log, so let's say that this is equal to question mark, right? Then that would mean that this whole equation is 8 to the power of question mark is equal to 1, right? So the only value that can make an exponent equal 1 if the base isn't 1 is 0. So that must mean that the question mark is 0. So to everybody who got that answer, yes, you are correct. Good job, it is 0. Okay, someone in the chat said they're confused, so ask whatever question you have. And remember, when you put your answers in the chat, please put the number of the question before it, just so we know which question you're answering.
I
Right.
don't get the algorithm on number 3.
All right, that's okay. We'll get to there in a second. But now we're going to go over the second question. So I'm going to use like a different example question to kind of explain this. So let's take log base 2 of 8, which equals 3. And so basically that's just asking you, to what power do you have to raise 2 to in order to equal 8? But you can also rewrite this as log base 2 of 2 to the third. Sorry for making you write so much, Ashani. Log base 2 of 2 to the third equals 3, because 2 to the third is just 8. And now, if you see this, does the question make more sense? So it's like the same pattern. Basically, going back to the question, log base b of b to the x is just asking, to what power do you have to raise b to in order to get b to the x? Well, obviously, if you raise b to the x, you get b to the x. It's a little bit confusing when you say it out loud, but the answer here is x, like a lot of you got.
So that was a trick question?
These are kind of all trick questions in a way. They're just designed to make you think. And then now for question 3. So don't worry if you're a little bit confused. We will go over it.
Okay, so for this problem, so firstly, we are solving, Okay, so firstly, let's look at this log base b of x, right? So what it's saying is b to the power of what is equal to x, right? And then we raise b to the power of that. So, we raise b to this power. So let's use an example. So we're also going to use a small example this time. So say that b is 2 and x is 8. So we would get 2 raised to log base 2 of 8, right? And what we get is 2 to the power of 3, right? So what that means is all we're doing is raising b to whatever the value of this is. So again, what it's asking you is what power will you have to raise b to get to x? To get to x, even though you are getting an exponent here, right? Sorry, it's not asking that. So what this is asking is b to the power of what is equal to x, and you're raising b to the power of that. So all you get is x, and I know it sounds like it's hard to understand when I say it like that, but what you're raising it to is, so what you're doing is you're doing 2 to the power of what is 8, and then you're raising 2 to the power of that. So 2, so all you're getting is this 8, because this log base 2 and this 2 cancel out, because log base 2 is just asking to what power would you raise it, and 2 is saying you're raising it to that power. So they cancel out. So yes, to everybody who got x in the chat, it is x. So good job. And I know I didn't explain the last question that well. So if you have any questions in the chat, please put them. And if you all don't have any questions, then we can move on. Okay, so the product. Sorry. Okay, so remember how multiplying exponents with the same base could be simplified to adding them. So this is how it looks in exponential form. So 2 to the power of 4 times 2 to the power of 3 is equal to 2 to the power of 7, which is just 16 times 8 is equal to 128, right? So since we can rewrite exponents as logarithms, we can write this property as a property of logarithms. So we get log base 2 of 16 plus log base 2 of 8 is log base 2 of 128. So we get 4 plus 3 is 7, right? So we get so what we get is log base 2 of 16 plus log base 2 of 8 is log base 2 of 16 times 8. So the product rule says log of x. So the product rule just says log a of xy is equal to log a of x plus log a of y. So let's take an example to show that it works. Log base 2 of 64 is equal to log base 2 of 16 plus log base 2 of 4. So let's write this out. So what we get is, so 2 to the power of 6 is 64, since 2 times 2 times 2 times 2 times 2 times 2 is equal to 64. So we get 6. And then log base 2 of 16, right, is just 4, since 2 times 2 times 2 times 2 is 4. And then we get log base 2 of 4 is 2, since 2 times 2 or 2 squared is 4. So we get 6 is equal to 4 times 4 plus 2, which is true. So that means that this rule holds. And make sure you guys are taking notes because it's hard to understand. Okay. Sorry, I did not see the chat, so
I have a question.
go ahead.
So if 64, if it was 64 in the middle, so how couldn't it not be like 32 and 2? Why does it have to?
It could be 32 and 2. No matter what we do, so long as some numbers multiply to 64, then log base 2 of A plus log base 2 of B would be equal to log base 2 of 64, so long as A and B multiply to 64. So if we take the example of 32 and 2, we get log base 2 of 32, which is 5, right? And then we get log base 2 of 2, which is just 1. And 1 plus 5 is equal to 6. So that means that it also holds for that. So we just used one example, and it isn't necessarily the only example that works. So does that explain your question?
Yeah, and I have another question. What is this math used for? Like, what does it mean?
Like, what do you mean by that question?
So like, what does this whole thing supposed to mean? Like 64, we know that it's 16 and 4, but does that make it another piece? Does that add up to like another something?
I don't know what you're asking. So are you asking why this works or?
Yeah.
Okay, so basically, the reason it works is because what we're doing is we're saying 2 to the power, sorry. So what we're saying is, say we have, so this is 2 to the power 4, this 16 is 2 to the power 4, right? And we have this 2 to the power of 2, right? Which is 4, sorry, right? And then we're basically doing these things multiplied together, 2 to the power 4 and 2 to the power of 2 multiplied together. And the reason for this is because this is equal to 2 to the power 6, which is what that 64 is, right? So the reason that we are using logs here, or the reason that it works for these logs, is because we're saying 2 to the power of what is equal to 64. So 2 to the power of 6, right? So that would make this 6. And then 2 to the power of what is 16? So that would be 4. And then we're asking 2 to the power of what is 4? So that would be 2. And if you remember, when we multiply two exponents of the same base, we're just adding the exponents, right? So that's it that this means, that we can add the exponents to get what the numbers would be when multiplied together. Does that explain your question?
Yes.
Okay. And someone asked if we could go back over the third problem. So which part specifically do you want to be explained in the chat? Or I'll just explain the whole thing. So log base, okay, so let's use an example, right? So let's do 2 as b, right? And x is equal to 16, right? So what we get is log base 2 of 16 is, and then 2 to the power of that, right? So what this means is that we have to, so what this means is we find this exponent, right? And all this exponent is asking for is 2 raised to the power of what is equal to 16, right? So we get 4, right? And now we're actually raising that 2 to the power of that. So we get that 16. So effectively, the log base b and the b cancel out, because log base b is asking what power do you need to raise it to get x, and b to the power of that is actually raising it to that x. So that means that our answer is x. Does that explain whatever questions you have, or you just type in the chat? Okay, I'm going to assume it does answer your questions, and we will move on.
All right, so the quotient rule is another property that logarithms can have. So let's go back to dividing exponents with the same base. And that can be simplified as just, say, subtracting the exponents. So you see there, 4 to the 5th divided by 4 to the 3rd equals 4 squared, because you do 5 minus 3, and that gets you 2 for your exponent. And if you multiply the whole thing out, you can see that that works, because, so that's the one on the right. 4 to the 5th equals 1024, 4 to the 3rd equals 64. And if you type that in your calculator, you get 16, which is 4 squared. So, but also, because exponents can be rewritten as logarithms, we can also take this property and rewrite it as a property of a logarithm. So first, we have log base 4 of 1024 minus log base 4 of 64 equals log base 4 of 16. And so if you go and individually solve this, well, log base 4 of 1024 is asking you, what power do you have to raise 4 to in order to get 1024? And that would be 5. You do the same thing for the other two terms, and then in the end, you just get 5 minus 3. 5 minus 3 equals 2, which is the same thing you did with like the powers in the exponent originally. So let's look at an actual generalization of how this rule works. This is something you're going to want to write down. So log base a of x divided by y equals log base a of x minus log base a of y. And so that previous slide was just explaining why that works, basically. And we're going to go an example. So take this problem using variables, log base c of e divided by d. And you can expand this into log base c of e minus log base c of d. And those two things are equivalent. All right, does anyone have questions here?
If not, we can move on. And again, if at any time you have a question, just put it in the chat or unmute. So expanding logs. So expand log base 2 of 8x. So in the chat, put your answer. And remember, 8x is 8 times x. So how would you be able to use log?
The rules are still written on the screen, by the way, at the bottom. So you can just take your notes from here.
Yeah.
All right, so let's maybe take a step back. So expand log base 2 of 8x. Which of these rules should we use when we're trying to expand this problem? Put your answer in the chat, product rule or a quotient rule. Think about what the argument of this one is and which one applies. Yeah, that's right. We're going to use the product rule. So now try to apply that. Try and follow the rule and apply that to the problem. Okay, so expand log, if you just look at the product rule on the bottom, the left side is like the condensed version of the log because it's smaller, and the one on the right side of the equal sign is the expanded version because it's longer. So we're basically asking you to take that problem and then turn it into the expanded version.
Okay, so I don't see very many people getting it right. So remember, we're asking you to expand log base 2 of 8x. Okay, so what we're supposed to do. So we know that 8x is just 8 times x. So using the product rule, we get log base, using the same base, right? So log base 2 of x, right? So x is the first thing that's multiplied. So log base 2 of 8. And then we'd have plus log base 2 of x, right? So what we would get is 3 plus, okay. So what we would get is this is 3, right? Because 2 raised to what power is equal to 8? It's 3, right? So we get 3 plus log base 2 of x. So I saw a lot of people saying 3x. Remember, you're adding them, not multiplying them. And even if you were multiplying them, you would still have the log base 2 that would not be removed. So make sure you remember the product rule and how to use it, right? Okay, second problem. Expand log base 4 of xy divided by 3. So you are going to be using both the quotient and the product rule in this scenario. So in the chat, type your answer. Okay, so the answer shown, so a lot of people are putting the wrong answer, right? You guys are not expanding it completely, right? So first, let's use the quotient rule, right? So we would get log base 4 of xy, minus 3, right? When we use the log base 4 of xy minus log base 4 of 3, right? So this, however, is not our final step, right? This is not our final answer since we can expand this, right? So we get this is log base 4. Wait, let me just type this. This is log base 4 of x plus log base 4 of y minus log base 4 of 3. And let me just draw in the bases, right? So we would get our final answer as this. Since we do have to use both the product rule and quotient rule, even if you did it in a different order where you use the product rule first, right? And you got like x, log base 4 of x, plus log base 4 of y over 3, you would still get log base 4 of x plus log base 4 of y minus log base 4 of 3. So these rules don't have to be done in any particular order. Okay, and the answer shown is not completely simplified. So make sure not to write down this answer, but the answer that I put on the board early. Okay, so condensing logs. Condense log base 3 of v plus log base 3 of z. So in the chat, type your answer.
Condense means like the opposite of expand, right?
Yeah. So basically, if you're given log base 2 of 8 plus log base 2 of x, you would find your answer to be log base 2 of 8x.
All right, that is correct. Log base 3 of VZ. So here, basically you just do the product rule, but the reverse of the way we did it before. So we combine VZ together. Since we're adding, we know to use the product rule. And then we can just combine VZ together in the argument for our answer.
Okay, if anybody has any questions, feel free to ask. Otherwise, we will move on to the next problem. Condensed log base 3 of 17 minus log base 3 of 6.
All right, here's a hint, guys. Take another look at the quotient rule. Look at the condensed form of the quotient rule, which is on the left, and make sure what you're doing applies to that.
And please make sure not to copy off of others, because a lot of the time people are wrong, and you're not learning by copying off of someone else.
Okay, yep, your revised answer is correct. It is log base 3 of 17 divided by 6. Because the condensed version of the quotient rule, basically when you expand it out, you subtract, and then when you put it back together, you have to divide the arguments. So the arguments here are 17 and 6, and your final answer will be log base 3 of 17 divided by 6.
Okay. If anyone has any questions, please put them in the chat. Okay, if you don't have any questions, okay, then another few problems. So expand these logarithms and condense these logarithms. So you have 6 minutes to do these. And again, if you have any questions, please feel free to ask us.
Wait, are you supposed to do all the problems, or is it
Yeah.
just
Do all the problems
Uh,
you have. a few more minutes.
Excuse me, why are the bases different?
For the last one,
On number, oh yeah, for the last one, number 3.
well, okay, sorry. Both of them are supposed to be 5.
Oh, okay.
Okay, so we will start explaining these problems. So for number 1, it was expand these logarithms. So this problem is log base W of 14p. So we can use the product rule and we get log base W of 14 plus log base W of p. Right? So wait, let me just write that out. Log base W of p. And so basically we're just using the product rule where it says that x times y and as the argument of log base a of x times y is log base a of x plus log base a of y. So let's see. Okay.
All right, so for number 2, here you would use the quotient rule. So when expanded, you would get log base 2 of x minus log base 2 of 5.
Okay, so for the next problem, it's asking find log base x of t times k times b. So we would get log base x of t plus log base x of k plus log base x of v, right? Sorry. So this would be our answer. Okay, 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 so Okay, so for the next problem, all we have to do is use the quotient rule. So we know that when log base a of x minus log base a of y exists, that is log base a of x divided by y, right? So we get log base 3 of 7 divided by x.
Okay, next one. So a three-parter. We're going to use the product rule. So our final answer will be log base 4 of 7xw.
Okay, so for the next one, it's asking us, okay, wait, sorry, for the next one, it's asking us log base 5 of r minus log base 5 of s. So let's just write a 5 over that. So what it's asking, so what the answer would be is we would use the quotient rule and we get log base 5 of r over s. So this would be our answer. So if anybody has any questions, put them in the chat. Otherwise, we will move on.
All right, so the power rule. You can see it on the screen there. So again, something you might want to write down. Log base a of x to the y equals y. And if you remember, this was one of our challenge problems. Oh, right. Oh, wait. Yeah, okay, so y times, it's similar to one of our challenge problems, and that equals y times log base a to the x. All right, so this rule can be seen as an extension of the product rule. So the argument here is x to the y, and so basically that simplifies down to x times x times x, y times. And so we'll take an example problem, log base z of x to the 4th. That equals log base z of x times x times x times x. And if we use the product rule there, you expand that to log base z of x plus log base z of x plus log base z of x plus log base z of x. And that simplifies to 4 times log base z of x. So basically that's the same pattern that you'll see up top right there. So basically, yeah, 4 times log base of x.
So make sure to write down the power rule. Okay. So common versus natural log. So on your calculator, you can do 2 types of log. The common log, which is base 10, but you don't write it as log base 10 of x. Instead, you just write it as log x, and it's understood to be of base 10. And the natural log has a base of e, which is a famous irrational number, and it's written as ln of x. So on your calculator, you can see, if you have this calculator, you can see log and ln are here, right? So you should be able to use them, right? So E, as shown in the animation below, is 2.718281828459045 and so on. All you need to remember is that it's between 2 and 3 and that it's almost 3. So challenge problems. And also just a thing to note, for natural log, when you're doing it, remember that it's base e and that e is an irrational number. So if you get a number that is like irrational, and then that is to be expected. When you do like ln of 4, you will not get a rational number. So make sure you know that you remember that it's irrational. Okay, so challenge problems. So problem number 1, if x to the power of 2 times y to the power of 3, that whole thing squared, is x to the power of a times y to the power of b, what is the value of a plus b? So this is also pulling off of knowledge from last class. So make sure if you have notes and you need them, then make sure to use them while solving this.
You are correct, everyone. The answer is 10. So a quick explanation. What we have to do here is first simplify. So first we square x squared, and then we multiply the exponents there. So 2 times 2 is 4, that equals x to the 4th. And then we square y cubed. So that equals 3 times 2, which is 6. And then our final thing is x to the 4th, y to the 6th. And 4 is a, 6 is b. So a plus b is 10. Nice
If
job.
any, yeah, good job. If anybody has any questions, remember to ask them. And if you don't, then we will move on. Okay, so next problem. So this is on radicals. What is the value of radical 5 times 6 times 10 times 12? All of that underneath the radical. And remember, when a radical is given and it has no number up here, any number right here, that means that it's a square root. So make sure to remember that.
So we're supposed to find the square root of all those 4 numbers multiplied.
Yeah. Okay, so a lot of people have put an answer in the chat, and yes, the answer is 60. So if you multiply everything underneath the radical, you get 3,600, right? So 5 times 6 is 30, and 30 times 10 is 300, and 300 times 12 is 3,600, right? So we get 3,600 underneath the radical, and then the square root of that is just 60, since 60 times 60 is 3,600. And since 3,600 is a perfect square and its root is 60, that's why we get that answer. So what is the integer nearest to x if 3 to the power of x is 1,500? Put your answer in the chat.
All right. Just in case you're confused, it doesn't say 3 to the 3x, it says 3 raised to the x. So you have to raise 3 to a power. What is the nearest integer to that power? Like, so x is not going to be a whole number, but you need to find the integer the closest to it. An integer is just like, it can be a negative number or a positive number, but it can't be, it can't have any decimals behind it. So it can't be like 1.2. And examples of an integer would be like -3, 1, 5. Yeah, like that.
an integer is just 1, 2, 3, 4, 5, 6, 7, 8. Or -1, -2, -3, -4, or 0. It doesn't have a decimal, as Yolanda said.
All right, so I think we can go ahead and explain this one. So the answer here is 7. And here's the strategy we're going to use to find it. So first, we're going to figure out what two integers x is between. So 3 to the 6th, we know is 729, and 3 to the 7th is 2,187. So x has to be somewhere between 6 and 7. We need to figure out which one is closer to. So we're going to go to the halfway point, which is 3 raised to the 6.5. And then that breaks down into 3 to the 6th times 3 to that 1/2. And if you break that down more, you get 729 times radical 3. Now, if you had a calculator, you could go ahead and type 729 radical 3 and see if that's like really close to, see if that's close to 1,500 or not. But pretend like we don't have a calculator. So we're going to use another strategy. We know that radical 3 is less than 2. So 729 times radical 3 would be less than 729 times 2. Now 729 times 2 is 1,458, and that's already less than 1,500. So that tells us that, that x will be closer to 7. All right, I hope that makes sense.
Yeah.
Cool.
Yeah, it does make sense. However, there also is an easier way to do it for all of you out there who want it to do it an easier way. So basically the easier way is that log, and this is a rule of log. So log base a of b is equal to log base anything, right? So you can have any number here. So let's call it x of b over log base x, which again is any number. You can choose whatever number. It can be e, it can be infinite, not infinity. It can be like 3,000. It can be anything, right? So log base x of b over log base x of a is log base a of b, right? So what we would do is we would see that this is 3. So this is log base 3 of 1,500, right? So what we could do, So what we could do is we could then see that the b would be 1,500 and the a would be 3, right? And we can use either ln or log, whichever works best for us. So let's say we use log, then we do log of 1,500 divided by log of 3, right? Divided by log of 3, and we get we'd get 6.65678, and so on, right? And we can see that this is closer to 7 than it is to 6 or to any other integer, right? So we could see that that's our answer. And just to see if it would, if this always works, we can also try it with ln instead of log. So we try ln of 1,500 divided by ln of 3, and we get the same answer, right? So if so you could always do that if you had a calculator, and that would be much easier. So the only thing to remember is that the base for both the logarithm and the numerator and denominator have to be the same. Otherwise, it will not equal your actual answer. So if anybody has any questions about that, feel free to ask. But just remember this rule. It's not something that comes up often, but when it comes up, it's really useful to know. So yeah. So I'll give you like a few seconds to write that down. And I think someone unmuted. If you have a question, please ask.
All right, so there's a little bit less than 20 minutes left of class. So we're going to give you guys a choice. Would you rather continue doing some more challenge problems, which might be more applicable to like, say, math counts, or we can do a Kahoot, which is basically just reviewing everything we've done.
Kahoot. Kahoot.
Check your voting chat. I think I know
Can you
what.
repeat the second
Okay.
choice? I didn't hear it.
Kahoot.
Ow. Can you repeat the second choice? I didn't hear it.
Second choice is a Kahoot.
The first one?
Yeah, first one is just continue to do more challenge problems.
Yeah, I'm just gonna go with what everyone says.
Kahoot by a mile.
Yeah, that's to be expected. So let's do a Kahoot.
Okay, let me, wait, sorry. Let me clear my drawings and, okay, wait.
And these slides will be posted in the classroom. So if you want to go and do these challenge problems yourself later, you can feel free to do so.
Yeah. And if you have any questions later on, feel free to like put them in the Google Classroom and like on these questions.
When does class end?
4:30. Okay. So we will give this a second to load.
Will the
And-
Kahoot be graded? No, but points are going to be given to the top 3.
Okay, wait, so let me just quickly log in and then I will start the game. Okay, I'm gonna stop sharing for a second.
All right, who thinks they're going to win this Kahoot?
Okay,
One person thinks they're going to win. Has everyone else already given up?
Yeah, Anushka's gonna be at least in top 3. Anushka's smart.
See?
I can agree with that.
Yeah, I know 3 of these kids and they're in some of my classes. Actually, Destiny is in all of my classes.
Yeah,
Wait,
but
no, I remember. I recognize you from Zeke, Anushka.
Yeah, I recognized your name and I saw your video camera on.
Yeah.
So we're gonna do the Kahoot or just talk about school?
yeah, we're doing a Kahoot. Let me quickly,
Can we do both? Is both
I mean, sure.
you can talk about school while you do the Kahoot, if you could manage to focus on math at the same time.
Yeah,
Yay, math.
okay, so the code is 1812178. So make sure to join and we will get started at 4:16 or whenever we have at least 10 players.
And you should put your actual name so we know who to give points to.
Or you should at least put something where we would know who it is, you know. Whoever wins this Kahoot will be getting like 3 points. And then, or sorry, 4 points. Whoever gets second gets 2 points. Whoever gets third gets 1 point. So, yeah. Okay, so we have 12 people, so I think we can get started. So exponents, radicals, logarithms. And I think you should
Excuse
still,
me?
Yeah.
Oh, I was trying to log into Kahoot, but I didn't know where to sign in on the app.
You don't need to sign in. You just go to kahoot.it and then you put in the game pin, which is on the bottom right of the screen.
Okay.
What are your points even for?
These points are just for the standings. Okay, so it was 196. So 14 times 14 is 196. And it's just a good idea to remember the first like 15 to 20 squares for math counts and stuff. So yeah. Okay, Kevin is in the lead. Number 2.
Haven't joined yet.
Okay, evaluate 6 to the power of 3. So put your answer in the chat. Or sorry, not put your answer in the chat. Put it in the Kahoot.
excuse me, I signed into Kahoot and I clicked one of the boxes and it's just loading. Oh,
Yeah, it will only show you if once the problem is done. So 6 to the power of 3 is 6 times 6 times 6, which is 216.
Well, my brain didn't
Can you
work.
wait
I
to
thought
start the
it
next-
was 3 times 36, not 6 times.
Oh, okay. So when multiplying two exponents, you can add the powers together only if what is true?
excuse me, it's only loading. I can't really see anything.
You should be able to see 4 choices and just click on one of them.
Yeah, but it's loading and it's
Yeah,
gonna keep on loading.
It only shows you if it's right.
I
on
don't
the
see any
10%.
questions.
Oh,
All right, sometimes Kahoot can be just like slow on some devices. So if you want, you can just put your answers in the chat to participate, although like we won't really be able to put you in the standings anywhere.
Okay.
okay, true or false? 3 to the power of 12 equals 3 to the power of 4 times 3 to the power of 8.
Oh, and Zane, you can private message them to me.
Okay. Okay. So it was true because the product rule says that the exponents added together, when they have the same base, is equal to a to the power of b times a to the power of c. So you should have gotten true. So right now, Dheeraj is in the lead. So simplify x to the power of 23, all of that to the power of 3. Okay, so the answer was x to the power of 69. 2 times 23 times 3 is equal to 69. And okay, someone asked for me to turn the music on. So I shall do that. Okay. I don't know if the music is playing. Okay. Evaluate 102938190023 to the power of 0. Okay, so the answer was 1. So remember, when you raise anything to the power of 0, it's equal to 1, and that's always true unless it's 0, which you don't raise to the power of 0. All right, so you should have gotten 1. And for the people who got 102938190023, that's that number to the power of 1, not to the power of 0. Okay, evaluate 2 to the power of -4. Remember what a negative exponent means, right? Okay, so it was 1 over 16. So the thing is, so it's 1 over 16. So the thing to remember is that when you have a fractional exponent, it does not go with the fraction, it goes with a radical. So when you have a negative exponent, it goes with the fraction, right? So you get 1/16, since it would be 1 divided by 2 to the power 4. Okay. Okay, so 81 to the power of x is equal to 9. What is x?
I totally misclicked.
Okay, so the answer is 1/2. Remember that 1/2 would be a square root, right? It would just be 81 square root, and 81 square root is equal to 9, right? So remember that -2, if we raised it to -2, the answer would be 1/81 squared. So good job, Dheeraj, for keeping a streak, and good job, Destiny, for having 3 in a row. Okay, evaluate 8 to the power 4/3. So remember what a fractional exponent means, and remember that your exponent rules. Okay, so we will be ending this Kahoot at 4:28. And sorry for the screen freezing, there's not much I can do. So 8 to the power 4/3 is the cube root of 8 to the power 4, right? So we would get the cube root of 8, which is 2, and 2 to the power 4, which is 16. So that means our answer is 16. Okay, so, radical 36 is the same thing as what? So remember what negative exponents or fractional exponents mean?
No, I thought it was something else. I thought there wasn't any radical, and oh my god, I thought it was just 36. I didn't see the radical.
Okay, so the answer was 36 to the power of 1/2, right? So what this is it's just square root. And some people said that they did not read it properly. That's very easy to do. So like, make sure like in the actual competition when it's not truly, like when you don't have to rush for every problem, make sure you just reread the question after you do it, simply because you might mess up if you don't. Okay. Simplify square root of 125. Okay, so square root of 125. So we all know, so we know when we factor out, when we divide 125, we get 5 times 25. So square root of 5 is not simplifiable, but we can simplify square root of 25, which is 5. So we get 5 squared 5, which is the red thing, right, which is the triangle answer. Okay, so the standings have remained the same. Simplify square root of 91. Okay, so square root of 91 isn't simplifiable. 91 is 7 times 13, and 7 times 13, neither of those are square root 7 and square root 13 aren't simplified. So the answer is it can't be simplified. So simplify 2 radical 3 plus 3 radical 2. Okay, so the answer is 5 radical 3s. So what this is 2 radical 3s plus 3 radical 3s, which is just 5 radical 3s, right? Which is 5 radical 3. Okay, so it's 428. So we will be ending this, right? Yeah, so third place is Destiny, second place is Ria, and first place is Dheeraj. So good job. Okay. So good job, everyone. I will. Okay. Stop sharing. Let me just. Okay, wait. So basically, we do have homework. Who's the link? Wait, no, I will share screen. Okay, right. So we do have homework. So I'm gonna put the link in the chat for you all to be able to do. So you all can do it right after class or anytime later, right? So just make sure to do it before it's due and it'll be good. So class is over, so I will stop recording.